This video is going to show you how to complete the problems out of your math book on page 84. So the directions say use the diagrams below to find the scale factor and then find the area of each figure. So just kind of looking at them real quick right here, I see that these figures, I know I'm supposed to find the area of them. They're just rectangles. Yeah, all of them are rectangles. So I know that the area of a rectangle is length times width. Okay? And that's just for rectangles and squares. If I could spell. And later on in another unit, in the geometry unit, we'll talk in detail about how to find the area of other shapes such as triangles and circles. Okay, so areas of rectangles and squares, you just take the length multiplied by the width, okay? So that'll help us later on as we figure out this problem. Alrighty, so example 1, I'm going to go ahead and examine the information right here. So this first one right here, that's the actual picture. It looks like it's 4 units because they just counted the little dashes right there representing the sides. So that's 4 units. Right here is 3 units, and that's the actual picture. I'm going to label that X, okay? And you'll see over here I've already created a table. So I'm going to go X and Y to represent that. And then we have a scale drawing. This side length right here is 6 units because they counted 6 units there for the side, and 1, 2, 3, 4, 5, 6, 7, 8 units for that right there. You'll notice that it started out small and it got bigger to get to over here. So I know an enlargement happened. And that's to refresh your memory. And you could also have said magnification. That's what happened. And since this second one right here, this second picture is labeled scale drawing, I know that this actual picture is similar to the scale drawing. Remember that symbol means similar. So these are similar to each other. And the criteria to be similar is they have to be the same shape. They have to have proportional sides, and I'm seeing they do have proportional sides, and I'll go into detail about why they're proportional. And they also will have the exact same angle measures because they're rectangles. So there's 90-degree angles in all of these right here, okay? So yes, they're similar, enlargement happened, and we got to figure out some stuff. So I see we got to find the scale factor. Well, let's go ahead and do what we've done in the past. So with the actual picture, this right here is 4 units. So under actual, I'm going to put 4 units. And its corresponding side, remember with the 1-to-1 correspondence, this one is 8 units. Okay? And then for the other side, I see 3 units. So I'm going to go ahead and write a 3 right there. And the corresponding side on the scale drawing is 6 units. Okay? So to figure out the scale factor, you know, it's just like finding unit rate or the constant proportionality or the constant ratio or the constant rate, all the same thing. You just go y divided by x. Okay? So remember, y divided by x. So I have to go 8 divided by 4. Well, and that's 2. Or if you want, you can go divide by 4, divide by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. 2 over 1, that's just 2. 2 divided by 1 is 2. So then this guy right here, again, y divided by x is 6 divided by 3. Let's go ahead and you can just go 6 divided by 3. That's 2. But you can also simplify it like this. So that's 2 over 1, 2 divided by 1, right there. So I know, folks, that the unit rate, you know, the scale factor is what I should be saying because it's geometry, is 2. And that fits this information right here also because an enlargement happened. Remember, when the scale factor is greater than 1, an enlargement happens. So our scale factor is 2. Okay, now they want us to find the actual area. So actual picture, we got to find the area of it. And remember, since it's a rectangle, it's length multiplied by width, okay? So we just go 4 times 3, and we get 12. And remember, when you have area, you need to label it units squared or square units. So I'm going to put that right there. Whenever it's area of even circles, triangles, anything, you got to label it square units or units squared. Units squared, or you could have also written it like this. Okay? Or you could have written out the word squared. That's all acceptable. Okay, now the scale drawings area. So again, it's length times width. So we're just going to go 8 times 6, and that's 48. Okay, and again, you could write it this way if you want, 48 square units. Okay, now it says value of the ratio of the scale drawing area to the actual area. So look at the scale drawing area. Well, the scale drawing area right here is 48 units to the actual area. Well, the actual area was 12 units. Squared is what I should be saying. And they want us to do a ratio of that. So they want the scale drawing written first and then the actual drawing. So one way that you can represent this is 48, 12. That's probably what you saw maybe in the previous grade level. We can also write it as 4 to 1. And if you're like, how did Hopkins get 4 to 1? Well, look, I went 48 twelfths, which is what I could have also said. We can also simplify it. Let's go ahead and divide by 12. Divide by 12. 48 divided by 12 is 4. 12 divided by 1 is 1. Okay, so I could write it like this. I could write the answer like this. I could write the answer like this. I could write the answer like this. Okay, those are all completely acceptable because they're all interchangeable. They're all equivalent, okay? All right. You should pause the video and try to do number 2 on your own, okay? But here's how you do it. I want you to take a second and examine the drawings right here. We have the actual picture and we have its scale drawing. Since it's labeled scale drawing, I know that they are both, this one and this one, are proportional to each other. They are also going to have the exact same angle measures, and I also know that they're the same shape because that's the definition of similarity. This is similar to this, so I know that there's similarity going on because of those 3 criteria. And it started out large and it got smaller, so I know that a reduction happened. So I want you to take a second. Do you remember what we know about the scale factor if a reduction happens? If a reduction happens, the scale factor is going to be less than 1, okay? So let's go ahead and, like we did up here, I want you to draw your table out. Yes, you do have to draw the table because I do want you to get practice with it. X is going to represent the actual picture. Y is going to represent the scale drawing. So let's label that actual and scale drawing. Spell it right. little shapes in it. So you can divide it however you see fit. I'm going to just go ahead and go here to here, so I see that I could find the area of this, and then I'm going to just chunk that like that. Okay, so the distance from here to here is 4, from here to here is 5. So I would go 4 times 7 to get 28 units squared right here. And I like to circle, I put the area inside there. Here I'd go 5 times 17 to get the area of this chunk, and that's 85 units squared. Then here I'd go 3 times 4, and that's 12 units squared. Then you'd add the areas all together, 28 plus 85 plus 12, and when you do that, you end up with 125 units squared, okay? Some students in class, they decided to chunk it this way. They went, there's a thing there, and they did it like this. And that's cool too, you could totally do that. If you went 9 times 7, you get 63 units squared. Then you go 6 times 5 is 30. Then you'd go 4 times 8 and get the 32, and you get the same answer. 63 plus 30 plus 32 is 125 units squared. So however it makes sense in your brain to cut it up, that'll work for you. Okay, I want you to pause the video and try this one on your own, and I will show you your answer. Pause it. Okay, this is what you should have gotten. Okay. For the summary, I want you to answer this question in a complete sentence. What is the difference between area and perimeter?